Hello everyone, I'm Nancy Burnham. I want to tell you about some work I did with Xinyoung Chen and Chris Hodges and their students and colleagues that's done very well in nanotechnology. I'm very pleased that in the last 10 years the paper has been downloaded over 1,500 times from the nanotechnology website and been cited more than 300 times according to Google Scholar. I'd like to tell you about the context for the paper. At the time, manufacturers of atomic force microscopes were supplying instruments that were good at imaging, but of course people also wanted to measure forces. And in order to have a good number for force, you need to have a good number for the spring constant. And thus, this paper compared calibration methods, of which there were about a dozen at the time, for AFM cantilevers. Here are example data from the paper. This is a thermal noise spectrum with the cantilevers hanging in the air without moving, without excitation. We take the signal from the photodiode and we plot the log of the mean square amplitude as the log of the frequency. And this straight line here is 1 over f noise, and then the dashed line is the simple harmonic oscillator, i.e. the cantilever motion. One of the points of the paper was that it doesn't matter whether you try to fit the peak area of the data, or you integrate up the area under the curve to get the spring constant of the cantilever. Those came out within 2% of each other. But I think the lasting contribution of the papers is not from this figure, but from the two tables that we provided. Table 1 was a summary of the different techniques for obtaining spring constants, and Table 2 was actual experimental data comparing 4 of those techniques for 10 different cantilevers in air and water. Now, 10 years later, it's routine that AFM manufacturers provide a means by which to calibrate the spring constant of your cantilevers, which of course means there are more good papers out there because more people have access to good numbers for spring constant and thus force. If you'd like to find out more, there's this journal's website. You can search Google Scholar for my name, and there'll be a list of papers there, about 5 of which subsequently are devoted to nanometrology. There's my lab website, and I have a YouTube channel where I give lessons on atomic force microscopy. Thank you very much for your attention.